All right, what we want to look at is we want to look at um, a condition of our of an impulse when we actually bounce. So what we want to do is we want to set up the following problem. We want to assume that we drop a bouncy ball from some height. Let's just say our initial height that we drop the bouncy ball from is 1.5 meters. And let's assume that the mass of the bouncy ball is 1 kilogram. A big, heavy bouncy ball, I guess. Now, so then there's, bounce. And after the bounce, the ball returns up, but it only returns to a height of 1 meter. So what we want to do is we want to think about what's the impulse on the ball from the ground, and then we'll come back and just assume some average time of the ball interacting with the floor to get an average force. So let's look at the idea of how much impulse did the ground deliver. So the impulse, we said, was equal to the change in the momentum. So in this case, we have some initial momentum, but our ball, we're going to have some initial momentum before we hit the ground and right after we come off the ground. But how do we get our velocity? Well, we're going to have to use energy considerations. So for here, what do we know? We know the ball has some initial energy. It has energy equal to mgh. And energy final is 1/2 mv squared. So we know the ball initially, when you drop it, right before it hits the ground, it has a velocity of 2gh. Now when the ball comes off the ground and bounces back up, it turns out that it's going to have a velocity. These just flip, and it's going to have a velocity of 2gh. So we can calculate the velocity right before. The velocity right before is the square root of 2g times 1.5, which is the square root of 4g. And the velocity after, when it's bouncing back up, is just going to be the square root of 2g. So, what can we do? We can now calculate our impulse, because our impulse, we said, is just the change in the momentum. So what's our final momentum? Well, it's the ball going up, which is mv final minus mv initial. But we have to remember that those velocities are vectors. So up is positive, so the impulse in this case is 1 times the square root of 2g. Now, how about the initial? Well, the initial is going down, which is negative, so it's minus 1 times negative square root 3g. And the negative times the negative makes this a positive, so the impulse is square root 2g plus square root 3g. So, what we can do is we could actually plug in our value for 2 times g and 3 times g and get a number. Yeah, real quick. This is going to be 2 times this is going to be 4.42. And this is plus 5.42. So we're looking at the impulse is 9.82 kilogram meters over seconds. And it's positive because when the ball moves towards the ground's pushing up. When the ball hits the ground and the ball is pushing down, The ground is pushing back up, and the ball hits and gets pushed back up in the positive direction, so the impulse is positive. So our impulse turned out to be 9.82 kilogram meters over second. Now, if we assume that the ball had an average contact time with the ground, the delta t, it interacted with the ground for 0.5 seconds, and then we had to calculate the average force up the ground. Well, we also know that the force times the average times the time, force average times time, is equal to the impulse. So what we can do is we can take our F average is our impulse over 0.5, our delta t. So in this case, it's 9.82 over 0.5, which is 19.64. And so the force average is 19.64 meters. So when we were looking at this problem, we used our energy conservation, pulling out some older tricks, to calculate the speed before it hits the ground. Then we flipped the energy conservation, remembering that the ball comes to a stop up here, so it has mgh again up here, to calculate the speed right after it leaves the ground. And so we calculated our speeds before and after the collision. That enabled us to get the impulse, which turned out to be 9.82. We said, well, it interacts for about half a second. So using that, we were able to calculate the force average that the ground exerted on the ball. And again, the force average is positive because the impulse is positive. The ball is being pushed up by the ground.